Hi, welcome to Applied Math in the Health Services Program, week 3 of this fun times. And I just wanted to give you some instruction, kind of help you with this chapter a little bit. It's probably more new for some of you. So you're introduced to the dosage formula in this chapter, which is really helping you, just a systematic way to help you find dosages when you're given an order from the doctor or the nurse or whatever. And then you've got to decide, hey, how many pills do I give this person? How many milliliters do I give this person? Okay? So this probably won't happen when you're a CNA, but as you move forward, you get more and more when you can administer medication. The dosage formula is pretty simple. It's just the letters are D, H times Q. Okay, well, what do those stand for? D stands for the dosage that's ordered. Okay, so that's kind of what's ordered or what you're supposed to give. All right, and that's supposed to be an R there. Ordered, okay? And this is the quantity that you have on hand, okay? What's on hand in your medicine cabinet, okay? And this is the quantity that this stuff comes in. So does it come in tablets? Does it come in like 5 milliliters? Like, what does it come in, okay? So this is the amount of medication you have on hand. This is what's ordered. This is the medication that you have on hand, what it comes in. Hi, we're back now, and the other option that you can use when you're calculating dosages, okay, instead of the dosage formula, you can also use unit or dimensional analysis, okay. For some of you, you may be familiar with this in chemistry. Some of you may not, or may not have done chemistry or don't know about what I'm talking about. I'm going to explain a little bit. The point is, though, this is good to use when you don't have the same units, okay. So if you have your D over H times your Q, okay, if the D and the H aren't in the same unit, sometimes it's useful to instead solve these dosage calculations problems with unit or dimensional analysis. Okay, and I'll give you some examples here coming up. There's 2 videos I posted about unit dimensional analysis. Okay, it's called with multiple conversions. Okay, I will give you some examples, but I won't necessarily explain everything. Basic gist is you put what you start with over on this end, the unit you start with. Okay, so if you're starting with milligrams over here, okay, and then the unit you want to end up with, you put over here. So if we want to end up with, well, how many tablets do we need to give this person? Okay, and then we go through, oh, let me redo that here. Okay, and we go through a multiplication of several conversion factors, okay, until we get to the end thing that we end up with. Okay, so here's an example of when you might use the dosage formula for your dosage calculations. All right, let's say you're ordered to give 250 milligrams, okay, of a drug by mouth to a patient, and you're supposed to do it and you have on hand, you have 100 milligram tablets, okay, and I'm going to put a 1 here because you have this on the medicine cabinet. They come in. Every tablet you have in the medicine cabinet comes in 100 milligrams, okay? So this is what we're ordered, okay? This is what we have on hand, and this is what the stuff that we have on hand, how it comes. It comes in tablets, okay? Now all you have to do is, a fraction symbol also represents a division, okay? So you could just take 250 divided by 100 times 1, okay, which a lot of you could do just on your calculator. Some of you could just do it in your head. Okay, one thing that I would encourage you to look for is reducing before you do your math. It'll sometimes help you go quicker. You won't necessarily have to reach for the calculator. Okay, for instance, 25 goes into 250 here. Okay, think about quarters. How many quarters go into $2.50? Okay, well, it's 10. So if I divide the top one by 25, I get 10. If I divide the bottom one by 25, I get 4. Okay, now if you look, I can even reduce this further. 10 over 4 is the same thing as 5 over 2. Okay, the reason I'm doing this beforehand, now my math is pretty simple. I take 5 over 2 is the same thing as 2.5. If you think, hey, how many 2's fit into 5? 1, 2, and then there's 1 part left over. So our answer then becomes 2.5 tablets. All right, so what's an example then of where you might want to use dimensional analysis? Okay, so for this example, if you're ordered to give 0.6 grams, okay, of a medication every 4 hours, the 4 hours really doesn't matter, okay? It's just how often you're giving it, but doesn't matter when we're considering our problem, okay? So 0.6 grams every 4 hours. And in the supply cabinet, okay, you have tablets, okay, that are labeled with a V, grains V. Now grains V stands for, hey, this stands for 5, so 5 grains, okay? So we have 5 grains. I'm just going to switch it to Roman numerals so we don't confuse ourselves here. Okay, we have 5 grains in each tablet. Okay, so one tab. Okay, 5 grains in every tablet that we have. All right. So now the question becomes, well, how do we get to how much we're supposed to give the person? Now, if you were doing the dosage formula, you just put this over 5 grains, but that doesn't work because we have grams and grains. We have to have the same unit. Okay, so in order to get this one to work, we're going to use dimensional analysis. Okay, and with dimensional analysis, this is what we start with. What do we want to end up with? Well, we want to end up with how many tablets. Okay, so I'm going to put tablets over here. That's my kind of my question mark I'm trying to get to. Now I got to multiply by several conversion factors, or maybe sometimes only one conversion factor, okay, to get to where I need to go. Now with this one, I want to go from grams, okay, and I'm given grains and tablets. Now, if I put my conversion factor that I'm given, 1 tablet over 5 grains, okay, because remember, each tablet has 5 grains. Okay, that's my first conversion factor that I'm going to work with. Now, why did I put tablets on top and grains on bottom? Okay, well, the grains were kind of incidental. I put tablets on top because I want to end up with tablets. Okay, put tablets on top, so I want to end up with tablets. I don't want to end up with a fraction of a tablet or the unit tablet under the denominator. That wouldn't make sense. Okay. All right, so I'm then going to multiply because I got to go even further. Because if I do this math, okay, grams, tablets, grains, I got units all over the place. Okay, I got to have units be able to cancel out. So all that I'm left with is simply tablets. And how I get units to cancel out, if you watch the videos, okay, is I've got to have the same unit on top somewhere, and that's the same unit on bottom. Okay, now these aren't the same, so I can't cancel them. But I'm going to put one more conversion factor in here. The conversion factor you're going to need, and it's not exactly precise. Okay, Google will give you a different answer, but for the problems that I'm going to give you, you want to calculate that there's 60 milligrams for every 1 grain. Okay, I'll repeat that. 60 milligrams for every 1 grain. Okay, so I'm going to put the grains on top this time because, again, I want the unit to cancel. Grain and grain. Okay, and I'm going to put 60 milligrams on bottom. Okay, now if you see I'm running a little short of space here, I'm going to have to actually add another conversion factor because I got my grains to cancel. Okay, I'm going to end up with tablets, but I can't, milligrams and grams are not the same thing. So I'm going to make this a little bit smaller here. Multiply by one more factor. I've got to change milligrams. I've got to get rid of the milligrams. So I'm going to put 1,000 milligrams up top is the same thing as 1 gram. That way my milligrams cancel and my grams cancel. All I'm left with is plain old tablets. Okay. Now with dimensional analysis, once we've set up the problem with what we're starting with and what we want to end up with, and we've made sure our units all canceled except the unit we want to end up with, okay, then all we have to do is multiply the tops and put it over the bottoms being multiplied, okay? So I'm going to take 0.6 times 1,000 and put it on top, 6,000 or 600. Okay. And I'm going to take 5 times 60, which is 300. And then I'm going to simplify my fraction. 600 divided by 300 is 2 tablets. All right, hang in there, guys. We're almost done. I'm going to do one example of where you can probably just use your head to figure these out, okay? And then one more for a dimensional analysis, just because that's probably pretty new and probably the hardest to tackle, okay? So there's an example where it says your doctor orders 20 milligrams of a medication, okay? So 20 milligrams is ordered, all right, and you have 10 milligrams in every 5 milliliters, okay? So 10 milligrams per 5 milliliters. Maybe it's like a children's Tylenol or something, okay? So how much do you give the patient? Well, you just look at this one. We got 20 milligrams we got to give him. Okay, it comes in a bottle where every 10 milligrams is 5 milliliters. Okay, how many milligrams? Well, 10 to 20, it's just 2 times 2, right? So we got to times the dosage that we are going to give them by 2. So 5 times 2 is 10 milliliters. Okay. So some of these you don't have to set up this whole long process. You can just kind of figure it out in your head. All right. So this is the final example of dimensional analysis. Now this one might look a little scary because it's such small quantities. Okay. So the order is only for 1/150th of a grain. That's very, very tiny. Okay. And you have in stock, okay, for every tablet, there's a 200 microgram, so 200 microgram tablets. Okay. So you want to know how many tablets you're going to give. Okay, again, the grain problems can kind of be problematic because they're not in the same unit that the doctor might, or the doctor might order in grains, and it doesn't come in that unit. So we got to do some unit analysis to make sure they match. Okay, so we write down at first for dimensional analysis what we start with. Okay, now it does matter with fractions here. Okay, I put the 1 on top, 150 on the bottom. Now, it's 1/150th. You can think of it as one thing, but for dimensional analysis, I'm going to think of it as the top and the bottom, okay? And the unit is going to go with it on the top. All right. Now, I'm going to end up over here with tablets, and I don't know if I'm going to have enough room because there's several different conversions I go through here. I'm going to squeeze this over. So, 1/150th of a grain, not gram. Make sure you guys understand this is a grain, okay? And we're going to end up with tablets over here. I'm just going to say tab. Alright, so I've got to do some conversions similar to how we did in the last one, except we have an extra thing, micro, instead of just regular grams. Okay. Alright, so I'm going to put down my first conversion just because they give it to me. That's what I'm going to put down as a fraction. Okay. Now again, I'm putting tablets up top because I want to end up with tablets on top. Okay. So one tablet has 200 micrograms, and I'm going to put micro for short. Now, I still haven't canceled anything out, so I got to keep on doing this until I can cancel out everything but the tablets. Well, if I cancel out micrograms, I got to put micrograms up here, okay? I could get it down to milligrams. If I did that, then I'd be able to convert and get rid of grains. Okay? So I'm going to go from micrograms to milligrams, and if you don't know that, you can Google it, okay? There's 1,000 micrograms in every 1 milligram. And doing this allows me to cancel out my micros. Okay. All right, now I've got milligrams and grains. Well, there is a conversion between milligrams and grains, and I've told you about it last problem. 60 milligrams, this is approximate conversion, remember, not what Google will give you. 60 milligrams is 1 grain. All right, so then our milligrams and our grains cancel. Whoop-de-doo. Yay. All right, now we're left with tabs. So now all we got to do is multiply the tops and divide it by multiplying all the bottoms. So 1 times 1 times 1,000 times 60 is 60,000. 200 times 150 times 1 times 1. Well, 200 times 150, if I take 100, that gives me 20,000. And 10,000 should be 30,000. Well, how many tablets? 60,000 divided by 30,000. We need to give the patient 2 tablets. Alright, thanks for watching. I will have some questions for you. Instead of a test, I'm going to put them on the discussion question. You'll have a page that you can look over and answer a bunch of questions, and that'll be your assessment this week. And then I will post the answers to all those assessment questions on Monday or either the weekend or Monday. I'll post the answers, so you can do the assessment questions, finish them up by Friday, and then I'll post the answers. And again, feel free, once you've posted, to fix your answers if you're looking at other people's responses, if you think they're right. And that'll be it. So do those practices. Okay, the pages out of the book, the practice problems. And then on the discussion board, do the assessment questions. And write any questions you have down on the discussion board, the forum for questions. And we will not have a Google Meet this week.